This lesson is about circle theorems. Circle theorems probably one of the topics that most students hate the most, mainly because there are so many of them and students usually don't know which one to use. Um, so in this lesson, I'm going to teach you how you can get better at circle theorems. First, we're going to learn all the 8 circle theorems, and we have to understand when to use which theorem. Okay, when the time comes. So I'll give you some cues on how to use what circle theorem to understand when to use what. Okay, right. So circle theorems. So we've got 8 circle theorems in here. So you see 4 in here. There will be more coming down. So first of all, the first one is called angle at the center is twice the angle at the circumference when both are subtended by the same arc. So the bracket one is optional, but you do have to write down the exact wording. Angle at the center is twice the angle of circumference. This is called the reason. So in a question, a circle theorem question, more than often they will ask you to write down the reason, state the reason every step, explain your reason, explain the steps you do, da 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 da. Then you will have to explain this circle theorem. Essentially, what it means is the center here, like an arrow, like this angle in here is double the one in here. So let's say if that's 10 degree, that would be 20 degree. Um, how to spot? Well, usually it involves the center of circle. Angles formed by the same 2 points, so you can see coming from A and B. So the angles made from A and B. So look up for points that shoot out more than one line. So you look at A and B, point A and B, they shoot out more than one line. So you can see there, and then point A in a line. So chances are this might be the one. The way I'd like to describe this one is called arrowhead or arrow. Okay, like arrowhead. Second one is angle in a semicircle is a right angle. So where you will see, if you see a triangle inside semicircle, then the angle there will be 90 degree. To remember, to spot it, it involves the center of circle again, and then when you have 3 points of circumference with a diameter, that's a right angle. So diameter is a keyword. So if you remember diameter and a triangle, so that was a right angle triangle. The way to remember again is semicircle. That's how it. Next one. 3 angles subtended at the same circumference by the same arc are equal. Um, Essentially in here from A and B, angles formed by the same 2 points again, so these 3 angles are all equal each other. So look out for points again, same one like question 1. Look out for points that shoot out more than one line. So you can see A and B shooting out a lot of lines are shooting out from A and B like fireworks. So any angles that made from the same 2 points are equal. The way I like to remember this one is like a butterfly. Well, you have to use a bit of imagination in here. There's a little butterfly in here. So, like a butterfly, like a butterfly. Butterfly. Anyway, butterfly. Next one, or you can like a crown in here. So like a crowny head. So if you think about like that, and then that's someone's head. Okay, that's me, probably me. Uh, anyway, like a crown. The fourth one is opposite angles in a cyclic quadrilateral add up to 180 degree. So angles opposite in a quadrilateral add up to 180 degrees. So W plus Y will be 180, X plus Z will be 180. This is the only one about quadrilateral in a circle. One point to note is all 4 vertices are touching the circumference. So again, this is the only one with quadrilateral. So when you say quadrilateral, you should be thinking about this circle theorem. Next one, let's move down. So we've got more. So we've got 5 to 8. Number 5, the alternate segment theorem. The one probably confused students the most. First of all, to spot this, you will need a tangent. Okay, it does not involve a center of circle, and it makes a set shape. So like this, like you can see in here, this little set in here. So I call this a set shape with a hook. Set with a hook. So that's how you remember that one. Okay, a tangent and then a set shape with a hook. Okay, so these two will be the same. Now, one thing students get confused is, or a silly mistake students make is they make this one the same as x, which is incorrect. Um, right, next one, question six. No, not question six. Theorem 6. The perpendicular from a center of circle to a chord bisects the chord. So if you've got center of circle, again, cuts the chord, and then these two will be the same length, so perpendicular. And then, sorry, bisect means cut them in half, and also perpendicular. Well, how to spot it? Well, if you know, you know. I can't say much because this is a special one. It doesn't come up a lot in GCSE, but if you do A-level maths, this one come up quite often in A-level maths. Number 7, tangent and a radius make a right angle. Do you remember this? A tangent and a radius that makes a right angle. There are nothing else that use a tangent and a radius because this one uses a tangent, but this one doesn't use a radius because this one does not involve a center. So this one, tangent radius. Next one, number 8, the last one. Tangents drawn to a circle from a point outside a circle are equal in length. So the way I remember is like a planet Earth. You have to use a bit of imagination. Imagine a circle is the Earth, and you got a little star from there, and then the star maybe or the sun is equal distance in here, something like that. That's how you. I don't know. You have to use a bit of imagination. Anyway, right. So what it means is that point A to B, if AB is a tangent and AC are also tangent, then AB will be the same length as AC. So two tangents from an external point makes two lines the same. Just note these two lines are radii, sorry, plural form, English, my bad. One thing I also didn't want to say is for this arrowhead, this is a tricky scenario where students usually do forget. It doesn't look like arrowhead, but they'll be thinking which side is it? So it's that one, 2x and x. If you want to be really good at circle theorems, the first and the most important thing for you to do is to remember all of them. So I would like you, before moving on, I would like you to get a piece of blank paper, write down the number 1 to 8, because there are 8 theorems. Next to the number, copy the reason. For example, the first one, the reason is angle at the center is twice the angle at the circumference, or theorem 2 will be angle in a semicircle is a right angle. So when you copy the reason next to the number and draw the illustration of each circle theorem next to reason. Use the buzzwords like arrowhead, semicircle, butterfly crown, set with a hook, etc. if needed, or you can make up your own buzzwords. Copy them as many times as you need to until you can remember them firmly in your brain. So you can do as many times as you can, and you can spread it out as many days as you want to. But I would suggest you maybe do it over 1 or 2 days so you can, make it a bit more efficient. A student who nails the circle theorem, who can do really well in circle theorem, first of all, is the one who I can randomly ask. So I go to the student and ask, what's theorem 5? Can you tell me what's theorem 5? And then the student will be able to tell me, okay, it's alternate segment theorem, and they can draw it out. Okay, they can recall immediately, and it's alternate segment theorem, and they can draw it out. So if we really want to get the circle theorems, if you want to avoid circle theorems being one of the biggest obstacle to getting your GCSE grade, that's the first step you want to do. Nothing good comes easy. So if you want to be good at it, you have to spend your time and effort in it. So there are a few more tips before we move on to examples helping you spot circle theorems. So the first one is look out for clues to spot out which ones are relevant. Like these ones, for example, you can see if you see a butterfly, a crown, it's something to do with angle subtended at the circumference by the same arc. Or you can see a diameter, maybe thinking about any triangle, think about right angle. So these are clues. Next, draw a sketch of theorems that can help you visualize your memory. So your memory, you're using less of a memory at the same time. So if you draw them out, you can easily pick and choose which one is relevant and which one is not. So you can do it by elimination as well. Be vigilant with radius. Sometimes they form an isosceles triangle. So we'll go on to the first example. Now, hopefully by now you will have done your memory test and memory revision about all the circle theorems, and you remember from 1 to 8 what circle theorem is what. For example, if I ask you, do you remember what is circle theorem 4? Yes, you're right. It's a cyclic quadrilateral. So opposite angle cyclic quadrilateral added to 180 degree. But if you don't, okay, then that's fine. What I suggest you to do is have the list next to you, okay, this list of circle theorems next to you, and then we're going to use it one by one and see which one is relevant. So it's like having this in your mind instead of having it in your brain, you just have it on the side with you. So let's have a go at this question. Work out the size of marked angle x. First of all, this the marked angles, we've got x and y. That's the center of circle. So whether you remember it or whether you have the list next to you, I want you to look at the theorem, see which ones are relevant, and write it down next to it that you think are relevant. Which theorems are you think are relevant. So we can see in here there's diameter, and we can see a quadrilateral. So the ones that are relevant is, first of all, the first one is cyclic quadrilateral. So circle theorems. Two are relevant. That's the one with the right angle. So I'll draw a quick one, so you can see. Draw a quick one out, like that one. That would be a right angle. And then, oops, if that's diameter, that will be the right angle. And the circle theorem 5, which is about the cyclic quadrilateral, if we just draw a random cyclic quadrilateral, these two add to 180, and so as these two. So with these ones, then we can do it, because we can see this one. There's a right angle in there. There's a right angle triangle. That's diameter, so that would be 90 degree. So what we know about y is y plus 36 degree plus 90 degree will be 180 degree. So the sum is 180 degree. They didn't ask you for the reason, but you should also write a reason. You would say angles. So angle in a semicircle is 90 degree. So if you do y plus 36 plus 90, that will be 126 degree equals 180 degree. So y will be 54 degree. So as x, this one will be the same thing. So if you do 50 degree plus 90, that's 140 degree. 180 degree minus 140 degree is 40 degree. Also, you should also explain why it's 180 degree, because angles in a triangle. So x equals 40 degree. Another example. Again, first question to you is, can you remember, or do you know which theorems are relevant to this question? I'll give you some tips. We can see a tangent. Now, even though this looks at a center of circle, but never mentioned about center of circle, if they want you to know it's a center of circle, they usually put a dot in there, or they will tell you it's a center of circle, but so that you can't assume there's a center without any other clues. So what we know is there's a tangent. There's no center. So if you can remember all the circle theorems, have a think about which ones are relevant and write down next to the question. If you don't remember, again, you can put out this list and have a look, see which one is relevant. As I said, there is tangent involved, so we'll look at one by one. The first one is no tangent, so we'll look at tangent. First of all, tangent is the alternate segment theorem that involves a tangent and also tangent and radius. So potentially we'll be thinking about 5 or 7. But 7, we need a radius. So let's look at 7. Look at this question again. There is no radius because there's no center, so you can't assume any of them is radius. So therefore, number 7 is not relevant. So the theorem that you should be thinking is about alternate segment theorem. So we can draw it out next to it first. So we can draw a quick one, alternate segment theorem. Okay. So we know that one is equal, and also that one are equal. So that's what alternate segment theorems do. It's a set with a hook. Okay. Right. So what else? We see there are some points that there are more than one lines shooting out of it. For example, you can see this point are shooting 3 lines like a firework. 1, 2, 3. This point is shooting 2 lines. 1, 2. This point is shooting 1, 2, 3 again. So you should be mindful about points shooting multiple lines, because for point showing multiple lines, there's one circle theorem that involves in that one, which is the butterfly, or sorry, the crown. Not this one because there's no center. So these 2 points showing a lot of lines coming out of it. So be mindful. So we're going to draw that one out. So it's like that one, that one, that one, showing multiple points out of this 2 points, showing multiple lines out of it. So we can have a look at tangent first. You can see clearly this definitely involves the auto-segment theorem. You can see the x in here, so it's a triangle in here, set with a hook. So we can see x being 55 degree, the reason being alternate segment theorem. And y actually would be the same, but y, so y would be this alternate segment theorem of y is like this. So y would be 55, not 55, sorry, 38 degree because of alternate segment theorem. Now what about z? Now you can see these 2 points, as I said, the point here and the point here shooting multiple lines. So we can see these 2 points are shooting the line like this. They make an angle 38, but they also make this angle z. So therefore, z will equal to the other angle that made from these 2 points, namely 38 degree. And the reason will be angle subtended. Oh, by the way, you can use this symbol for angle, like an L shape, but with an inclined line in here. Subtended at circumference by same arc. All right. So here comes practice question 1. I would like you to work out all the marked angles and give reason for every working step. Similar to the previous example I've shown you, a structure of a question approach a circle theorem question would be first look at the circle and recall which theorem is relevant, or sorry, theorems are relevant. Draw them out first, like my previous one. You can see I draw a little sketch in here just to remind myself, okay, these are probably relevant. Then that will make your mind easier, less work to do at the same time. So pause the video, have a go at the question. When you need my detailed explanation, you can play the video. Hey, well, if this is not a symbol of arrow, I can't tell you what else this involves. So this is about the arrowhead, which is about the circle theorem 1. So you should be thinking doing something like this. Center, 2x, and x. So that means if we compare that, that means whatever's on top, that will be half of whatever is in center. So y, in this case, y would be double of 47 degree, which is 94 degree. And the reason would be angle at the center is twice the angle at circumference. Now, what about value of x? Hopefully you do notice these two are radius, so these will be equal in length. So that's equal in length, that's a isosceles triangle. So if isosceles triangle, the base angles are the same, so that also be x. So if we know y is 94 degree, we can do 180 degree minus 94 degree, which is 86 degree. So you can say angles in a triangle at 180 degree, but angles in triangle is usually sufficient enough. So x equals 86 divided by 2, which is 43 degree. For question B, hopefully you do see a cyclic quadrilateral. So cyclic quadrilateral, the circle theorem that involves it is the opposite angles up to 180 degree. So that should be the first thing you should spot out. 105, that will be 75 degrees. So 180 degree minus 105 degree is 75 degree. And the reason you have to give is because opposite angles in cyclic quadrilateral add up to 180 degree. And therefore, x will be 180 degree minus 105 degree, or minus 75 degree, so minus 75 degree, which is 105 degree. The reason being is x and this angle 75 makes a straight line. So you will say angles on a straight line. So you are allowed to use this abbreviation. That's fine. Okay, symbols abbreviation. So angles in a straight line after 180 degrees. That's for therefore we know x is 105 degree. Now, but for y, you will have to use the same thing, but this time opposite way around. You will have to work from 180 degree. So let me use different color for the y. So 180 degrees, so we can work that one out. So that will be 180 minus 180 degree will be 72 degree. Again, the reason will be angles on a straight line. And then y plus that angle 72 degree will be 180. So y equals 180 degree minus 72 degree, which is 108 degree. And that will be, again, opposite angles in a cyclic quadrilateral. Now, you can't say y equals 180 degrees straight away with that work at 72 degree because there's no direct reason why y will equal 108 or x equals 105. And the last one. So this time with a tangent, we can see a tangent. So circle theorem that involves a tangent is, again, alternate segment theorem. So like the one with a set shape, alternate segment theorem, because you can see a triangle in there as well. But also one that involves the diameter is the semicircle one, the right angle one. So that's a sort of two theorems that you should be recalling. So in here, we can work with it. So first of all, alternate segment theorem. That's a set with a hook. That's going to be 74 degree. So that angle we'll call alternate segment theorem. So if we know that 74, then easy peasy for x. X is going to be 180 degree minus 74 degree, which is 106 degree, because angles on a straight line. Now, what about y? So y takes a bit of time to work out. First of all, what we know is, again, if you recall these circle theorems, you can see drawing them up is going to be quite handy, because if I know I've used that one, chances are I'm going to use that one. So where can I use that one? Well, that's my right angle. So my right angle, that's a right angle because angles in a, sorry, not angles, angle in a semicircle is 90 degree. So therefore, for y, we know angles in triangle after 180. So y equals 180 degree minus 90 minus 74, which is 16 degree. But you do have to say because angles in a triangle. Hopefully you get them all right. Here comes practice question 2. Have a read through of the question and make sure you give reason of every stage of your working out. In your exam, this question probably worth 4 marks. There'll be at least 2 marks dedicated for the reason. So make sure you do put them in. Have a good question. When you're ready for the answer, you can press play. Again, first step, you should be thinking about which theorems are related to this. Well, you see, points A and D are shooting a lot of lines coming out. Well, if there are more than 2, we say many. AB, AC, AD, like kids, you know, when you see a parent with more than 2 kids, you say, oh, you've got many kids, you know. So ABC, so A and D are showing multiple lines. If they're showing multiple lines like fireworks, then you should be thinking about the crown theorem. This theorem for crown, they are all equal, or like similar to butterfly one, which is the same thing in here. Butterfly. Okay. What else? Well, don't miss out BD's diameter. If BD's diameter, it means, so there's only one circle theorem that involves a diameter, which is the one with the right angle. Okay, so BD's diameter. In other words, that means we know angle BAD is going to be a right angle. So we can say right in here, angle BAD is 90 degree. The reason being is angle in a semicircle is 90 degree. So you'll probably get 1 mark already from based on this line, or actually 2 if you got the final answer correct, because 1 mark for the working out, 1 mark for work out 90 degree, and 1 mark for working out the telling the reason. The second one, what we know is, now if we want to work out the x value, we want to work with this triangle. If we know 90 degree in here, what will be useful is to work with the angle DBA, this DBA angle in here. Well, we can find that because this angle will be same as 43 degree for the butterfly theorem. You can't say that. So you will say angle DBA or ABD equals to angle ACD, which equals to 43 degree. The reason being is you have the right reason. That's why it's so important as you copy it out. You have to remember it. Angle subtended at circumference by same arc. So if we know that's 43 degree, that's 43 degree, then therefore x will equal to 180 degree minus 90 degree minus 43 degree, which is angles in a triangle. This one probably get no mark, but you never know. So x equal to, the final answer will be 47 degree. Practice question 3. I deliberately put a more complicated question in here because some of the circle theorem question you see in exam, especially in the later part of the exam paper, when difficulty gets a bit higher, a bit more difficult, then they'll put a more complex circle like the one you see in here, where you can't really see what theorems involved straight away. For example, the previous one you can clearly tell it's about the crown one or the right angle one, but this one is not as involved. It's simple because you can see there might be many of them involved. This is why, again, you need to remember all of them, have them all imprinted in your mind or in your brain, so you can use it as and when. I'll also suggest you to draw as many circle theorems that you think that is involved in here as possible before you begin. Have a go at the question. When you're ready for the answer or my explanation, you can press play. So there are more than one way to do this type of question. So my explanation will explain one of them. And there are different order you can work out the values as well. Okay. So I'll probably start with, I see a tangent in a triangle. I like to use alternate segment theorem. So I can see in here already, you can see a set with a hook. Now, note, you can't use this one here. You can't use this one here because this triangle is not completed. So you can't use that AO line. You have to use the full triangle. You can see AD is completed, therefore we can use that. So what we know here is W equals to 42 degree. The reason being alternate segment theorem. Okay, so we found 42 degrees, so we're quite useful. Just write it down there. Next one. What else do we know? Well, we know OA and OD, they are both radii. So you have to sort of note these because these are radius. So what we know is if they're radius, that means that these two base angles are going to be equal. So if they're equal, so what we can tell is 180 degree minus 110 degree, which is 70 degree. Half it, which is 35 degrees. So 35 degree each for these ones. I'm not sure if they're useful, but with this type of question, you do want to have as much information as possible before you move on. So what else do we have? All right, we also see an arrowhead inside a circle. So this arrowhead in here. So arrowhead. So if you see an arrowhead, hopefully do you remember, if that's x, this will be 2x. So therefore, Z will be half of 110 degree. So Z equals 110 degree divided by 2, which is 55 degree. The reason is it's not arrowhead. You can't say arrowhead. You have to say angle at the circumference. Angle at the circumference is half, or you can say angle center is twice, is half the angle at center. Okay, right. So once we know Z is 55 degree, what else do we know? Well, can we work out y? Actually, we can because there's another alternate segment theorem. So if I use different color, it's starting to get a bit confusing because there are many colors coming in. So let's use this color. Hopefully you do see that. So y is going to be same as z. So let me rub that off. So y will equal to the z value, which equals to 55 degree, and the reason being alternate segment theorem. Right? So last but not least, we need to work out x. So how can we work out x? Well, with x, you can see x is involved in two triangles. The bigger one, where CAD, the bigger triangle, or the smaller one, CBD. So which one to use? Well, if we use the smaller one, use the smaller one. Because if we use a big one, it's not impossible, but it might be actually. Because the reason being is we don't know this angle here. If we want to see AD, we must know the full angle in here, the small angle here, which is unknown. I don't know if that's possible to find. There might be, but it's a long way. The easier one is to find the angle CBD, this angle here. Because this angle is 180 degree minus Z minus 55 degree, which is 125 degree, because angles on a straight line. So therefore x equals 180 degree minus 125 minus 42. Reason being angles in a triangle. Angles sum in a triangle. Angles in a triangle. So x therefore equals to 13 degree. And that's how you tackle circle theorem. Having them all in your mind or on a paper. Of course, you can't have that paper in the exam. Therefore, have them all in your mind. Have the reason next to the illustration as well, so you can remember which one is which. If you want, you can draw them all out in the exam before you begin a circle theorem question, if it's a difficult one, like question 3. But for question 1 and 2, hopefully you can remember straight away which ones to use.